much for having me today. I'm delighted to join the Future Medicine Science March in Berlin. And let me say straight out that we are at the cusp of a new era in brain research. And this is because unprecedented technology is now put at the service of science. Many neuroscientists among you will remember studying the firings of single neurons. And it feels like yesterday. It was yesterday. From single neurons, the field went to populations of neurons in different regions of the brain. Today's research spans multiple scales in space and time. So it's a completely different world. Nobel Prize winners such as Edward Moser call this a revolution in neuroscience because technology suddenly made possible to record simultaneous activity from thousands of neurons with known connectivity. All this can now be done in cellular resolution and over duration of long behaviors. Of course, many questions remain to be answered. That's why it is so fascinating to be in this research now. For example, how does the activity of the neurons lead to high-level brain functions, such as memory, planning, or thinking? How does the brain switch from using one set of recurrent neural networks to another? Or what's the role of the brain also in the evolutionary context? Is it to explain the worlds in which we find ourselves or help us survive and make the most out of it? These are some of the questions that I think many of researchers are struggling with today. In a taste of most recent discoveries, Human Brain Project scientists have proposed that different subnetworks process information in the brain at different speeds. They call them the slow updating network, the SUN, and the fast updating network, the FUN, with multi-storage core that belongs to both of them. Such discoveries help us know more and more about the brain. And understanding high-level cognitive functions is at the heart of understanding the course of diseases, where these functions are compromised. eBrains, the project I have the privilege of co-leading with our distinguished scientific team, will be a top-level enabler to address these challenges, making the most of the technological revolution that I mentioned. eBrains, to decode the term, stands for European Brain Research Infrastructures, and it is unlike anything else in the world because it aims to go deeper into the brain and wider across the scales. And it is entirely co-created with the researchers. So eBrains is a digital infrastructure at the interface of neuroscience, computing, and technology, including AI, and I will come back to AI in a second. It is a major outcome of the Human Brain Project, one of the world's largest scientific programs to study the brain, which runs until 2023. So what difference does eBrains make? Let me answer this question. So it is a one-stop shop offering scientists and developers the most advanced tools and services for brain research. From the knowledge graph, the data sharing repository, helping the scientists find and share data they need to make their next discovery, through data curation, next generation brain atlasing, onto modeling and simulation platforms, and AI-based analysis. So instead of going to different places, which you would normally have to do, you will now be able to come to eBrains and get a package of tools at once. This will be the most comprehensive set of services available anywhere for multi-scale brain research, with a service provision that is curated for the individual needs of researchers. Let's take the example of brain atlases, where we link cellular data with data on other aspects of brain organization in an unparalleled fashion. The Unique Brain, part of eBrains, is the first 3D atlas of the human brain, showing the variability of the brain structure with microscopic resolution. Most atlases today offer a resolution in the millimeter range, and they do not allow scientists to obtain information about thin fiber bundles, cortical layers, microcircuits, or cells. This is why we need to go deeper. And our scientists in Human Brain Project, together with partners at McGill University, are now aiming to develop a brain model with an accuracy of 1 micrometer and processing several petabytes of neuroscientific data along the way will be necessary. eBrains empowers the community to use exascale computing, take advantage of powerful high-performance analytics powered by a network of European supercomputers with a full spectrum of specialized services. So what difference do we aim to make through this infrastructure? In the area of medical applications, this is about diagnostics, it's about surgery, prosthetics, and drug screening. Neuroimaging, in combination with the eBrains multi-level atlases, provide a key support for diagnosis and therapy planning. Such tools will help to interpret the results more accurately and lead to better guided interventions in patients' brains. Physicians will be able to craft personalized brain models. eBrains could also allow for developing better software for deep brain stimulation in patients with Parkinson's. Microstructurally plausible information on target brain regions could help in the surgery of brain tumors. One example of which we are particularly proud is the epileptic virtual patient. The epileptic virtual patient uses the state-of-the-art virtual brain simulator available through eBrains to develop patient-specific individualized brain models to help improve surgical outcomes for epilepsy patients who cannot be treated with drugs. There is a sizable group of such patients. A clinical trial of this technology is now ongoing and planned to end in 2023. Another example is a project aimed at restoring vision in blind people using electrical stimulation of the brain. Peter Railsema and his research group in Amsterdam use eBrains atlases to ensure they target the right part of the visual cortex. So this is a project that will develop a prosthesis with thousands of electrodes driven by adaptive machine learning algorithms, helping millions of people with impaired vision. eBrains is also about access to clinical data, which is essential for therapeutic advances. The eBrains medical informatics platform, currently installed in over 30 hospitals, allows for creating robust profiles for brain disorders, including rare diseases, and for benefiting from the statistical power of a sizable combined volume of clinical data. We are also preparing right now a system of secure sharing of data. We want to become part of the EU-driven project on building a European health data space, something which is, of course, essential for the future development of therapies. Today's advances would not be possible without the support of artificial intelligence. In fact, brain research has a completely synergetic relationship with AI. Unlike many other disciplines, this is about a two-way street, meaning that it will greatly benefit from AI tools, but it will also pay back, so to say, by contributing to development of AI in the future. AI is particularly well suited for addressing the complexity of the brain, which is unparalleled with 86 billion neurons, each with thousands of connections with other neurons. The amount of data in single images and the complexity of that information is such that no scientist can analyze them on her or his own. So brain research desperately needs artificial intelligence and its pattern recognition functions. And eBrains users benefit from deep learning algorithms for segmenting brain regions in high-resolution scans of brain tissue. There are also specialized treatments adjusted to patient specificities. Monte Carlo Markov chains techniques are used in epilepsy surgery, and big data analysis are helping to identify disease markers, and Bayesian inference is used for brain activity analysis. But it is a two-way street, as I said, two-way relationship, because AI still has plenty to learn from the brain. Both brain and current artificial intelligence are recurrent, but they are recurrent in different ways. AI relies on single recurrent neurons and lacks the dynamics of the brain with its bidirectional connections with the feedback loops, which pass the information in reverse direction. So there is therefore a lot that AI can still learn from the brain. One of excellent examples of how this synergy works is the learning algorithm developed earlier this year by the Human Brain Project scientists led by Professor Wolfgang Maass. Integrating learning into mobile hardware could do a lot to save energy and remove one of the biggest hurdles for broad use of artificial intelligence. It is worth recalling that the brain only needs 20 watts, and this is a millionth of the energy of a supercomputer. So scope for brain-inspired solutions is enormous, and that's why it's really a two-way street, a two-way relationship. So let me finish by saying where eBrains wants to be in the future. We will want to be much bigger in the area of public health and medical applications. And this is really a call to action that follows directly from the fact that 179 million Europeans suffer from a neurological condition. And in the midst of the COVID-19 pandemic, we clearly now have a mental health pandemic. So the urgency of addressing these issues is enormous. And we are committed to developing eBrains at the service of brain medicine. We could not do otherwise. We would like to be an important actor in developing the future European partnership for brain health that is likely to emerge in the next few years on the European scene. This means that our tools can and should be taken to a new level as well, helping to better understand and manage behavioral or emotional dysfunction, develop predictive models in mental disorders, or derive concepts for language learning and language therapy. And we are looking at those plans right now very intensively. So concluding, it is sometimes said that brain research is a bit like physics in the 19th century, namely ahead of its most important breakthroughs. Technology today offers us unparalleled opportunity to develop a set of principles that will explain how the brain functions. And this can be overwhelming and intimidating, or it can be thrilling and fascinating. And my plea today is to treat it as a fascinating challenge, as a fascinating journey helped by technology and helped by artificial intelligence in particular. Thank you very much.